Good afternoon. Well, it's afternoon for me. I'm not sure about for you. Today we're looking at Bernoulli trials and the Bernoulli probability distribution. I really don't like how the textbook introduces exercise 17b. It's a lot all at once. So I'm going to break it down into several things and get you to do certain questions after each thing. But first of all, we're going to look at what Bernoulli trials and the probability distribution actually is. Now, 17a got us to do a whole bunch of questions to do with these, but now we're looking at it more formally. So with the Bernoulli trial, we have one single trial. Two outcomes. These can be success or failure. And the probability of success, we're going to call P. And the probability of failure, well, if it's either success or failure, it must be 1 minus P, and we also call that Q. So what we do is we say, let this variable called X, just a generic variable, don't stress, don't get too caught up on that, equals 1 if success, and X equals 0 if we have a failure. So if we had, if we were flipping a coin, then we get a 1 if we flipping a coin. If we were rolling a dice and wanted a 6, then X would be 1 if we roll a 6, and if X would be 0 if we rolled anything other than a 6. And hang on, sorry. Then we have certain things that we want to know about this. We want to know the mean, which is also known as the expected value. Now, this mean, the expected value we have, well, if someone was paying us $1 if we got a success and the probability of getting the success was P, or they were paying $0 for a failure and the probability of getting a failure was 1 minus P, then the expected value we'd get is literally just P. So if they were giving me $1 if I rolled a 6 and no dollars if I rolled anything else, then the expected amount of money I'd get is 1/6 of $1. You'd think that's weird. You're either going to get $1 or $0. We don't think like that in maths. Take your logic elsewhere. Don't be reasonable about this. I'm going to get 1/6 of $1. Don't ask me what 1/6 of $1 is, though. My brain's not working. 16.67 cents. That's a bit mean. So, expected value of X equals P. That's a good formula to know. I'm going to highlight it. And then the variance tells us how far we could get from this, dollar. So, I'm expecting to get 1/6 of $1 back, but maybe I'll only get 4/6. Maybe I'll get 4/6, or maybe I'll only get 2/6. Get 1/12. I don't know. Okay, I really shouldn't have done this with $1. The variance is going to be the expected value of X squared. I'll go into what that is. Well, that X, by the way, is, this X are these ones, minus the expected value of X squared, yeah? Now, this means the expected value of X squared would have been 1 squared times P plus 0 squared times 1 minus P. And we've got that whole thing minus the expected value of X squared, so minus P squared. So that gives us 1 squared times P is P. 0 squared times 1 minus P is 0. P minus P squared, which gives us P 1 minus p, which equals pq. Now, the useful formulas from this one to know is that one's pretty good to know. Oh, we call this big X, by the way. The big X. Actually, I'm going to drag that to the one above just in case you forget what Q is. You can get by the whole course without using Q. So it's that. And then finally we have the standard deviation. Which is the square root of the variance. So we call standard deviation sigma. So that's going to be the square root of P1 minus P. And that's the other useful formula to know. So if I give you an example question over here, if 1 in 200 Australians has COVID-19, and I choose one from a crowd. So Bernoulli is only if you're having one trial, and I choose one person from a crowd. First one, what is the probability that they have coronavirus? Is the probability that they are infected. No, I can't spell. Number 2, what is the mean? The expected value of infectedness. Number 3, what is the variance? And number 4, what is the standard deviation? Okay, so 1 in 200 people are in the have COVID-19, so that means P equals 1 over 200, which is what, 0.005? Yeah, 0.01 is 1%. Which means the expected value so E of X equals P, which is 1 on 200. The variance is P times 1 minus P, which is 1 on 200 times, what, 199 on 200, which gives us 199 on 199 on 40,000. And the standard deviation, so sigma equals the square root of the variance equals the square root of 199 on 40,000, which is root 199 on 200. Yeah, that's it. That's Bernoulli trials and the Bernoulli probability distribution. Oh, just to let you know, this thing here is what I mean by the Bernoulli probability distribution. But you also need the information prob equals P, prob equals 1 minus P. That's it.